Okay, this is lesson 102. Today we're going to evaluate logarithms by converting them to exponential expressions. That's your objective for today. If you're on the video, you should pause it to write this down. Okay, so we learned about logarithms. Logarithms are the inverse of exponents, so they are the opposite. So when you think about that, you want to know that there's a relationship between the two. Yesterday we learned how to convert between exponential equations and logarithmic equations. So yesterday we had like 2 to the third is equal to 8, and therefore we could write this as log base 2 of 8 is equal to 3, right? Is equal to 3. And so we learned how to convert that, okay? But what if I just gave you this? What if I just gave you log base 2 of 8? What's this equal to? I just gave you the answer. What is it? Or we're thinking 2 to what power is equal to 8? Right? 2 to what power is equal to 8? 3, right? So when we see this, we know it's equal to 3. And that's the goal today, is we're going to learn how to look at a logarithm that is an expression by itself, and we're going to be able to know what the amount is, okay? So here are the steps. If you are on the video, you should pause and write them down. So we're going to set the expression equal to 0. Then we're going to rewrite the logarithmic equation as an exponential equation. Step 3, find a common base on both sides of the equation. Step 4, once the bases are the same, we're going to set the exponents equal to each other. And then step 5, we're going to solve for x. Okay? So here we go, numbers 1 and 2. Okay? So number one we could basically do in our heads, but I'm going to show you the process for it. So number 1, we got 2 to what power is equal to 4? We could do that really quickly. What, 2 to what power? 2, right? So we know it's 2, right? But we can do it. We need to know how to do it the procedure, because sometimes they get more complex, they get more difficult. So we can rewrite this. We could set this equal to x. We say we don't know what it's equal to, and then we rewrite this as an exponential equation. So 2 to the x is equal to 4, and then at this point we would want to find a common base. So I know that I could use a common base of 2. I could rewrite 4 as saying 2 to the second power, and then we got 2 to the x here. And then we have a common base. When I have a common base, look at my exponents, we can set them equal to each other. So we have x is equal to 2. And we have our final answer here. X is equal to 2 here, right? So sometimes the exponents will be more complex where you have to solve for them, but they're pretty straightforward, okay? But again, I know number 1 was super easy. We could have done this in our head, right? But I wanted to show you the procedure. The procedure, again, you set the logarithm equal to x, convert it to an exponential equation, and then you're going to turn it into an equation with common bases on each side. Once you have the common bases, then you can combine your exponents, set them equal to each other. Okay, that's number 1. Number 2, 3 to what power is equal to 1/27th, right? Log base 3 of 1/27th. So the first thing you do is set it equal to x. Then you're going to rewrite this as an exponential equation. You got 3 to the x is equal to 1/27th. Okay? And then we're going to ask ourselves, what base can we use that's common on both sides? I know 3 to the third power is equal to 27, right? So 3 to what power is equal to 1/27th? Well, what's 3 to the negative first? Isn't this 1/3? Right? 3 to the negative second is equal to 1/27th. 3 to the negative third, right? I'm sorry, not 3 to the negative is equal to 1/9. 3 to the negative third is equal to 1/27th. Good. So we're going to rewrite this now with what did I just do here? We're going to rewrite this as 3 to the x is equal to 3 to the negative third. I just converted my 1/27th fraction into this. Now we have a common base of 3, so we're going to set our exponents equal to each other. So we got x is equal to negative 3, and that's it. Okay? That one's a little bit easier. All right, questions on numbers 1 or 2? Okay, good. So let's have twos in each group. Let's have you discuss. Pick a problem to share with your group. How did I do this procedure so we know what the how to evaluate the logarithm? Ready, set, and go. We're going to number 3. Sorry about that. Okay, number 3, evaluate the expression log base 2 of 8. Okay, so we can do this one in our head. What is the answer?
2 cubed equals 8.
So what is this equal to? 3, right? We're going to do it the long way, though. So if you were to do the long way, we're going to set it equal to x first, okay? So 2. And then we're going to write 2 to the x is equal to 8. So let's do this one together. We know the answer is 3 already. Okay. What's a common base you could use on both sides? 2. So the left side's good. 2 to the x. What about the right side? How can I rewrite 8 as the base of 2? Good. 2 to the third. That's right. So we got 2 to the x is equal to 2 to the third. Bases are the same. Therefore, the exponents are equal. So now we're just going to write, what's our final answer? X equals to what? Good. That's the answer we got, right? That was the value of our logarithm. Okay? Make sense?
Yes.
Good. Number 4 by yourselves. And then show me your answer. I'll give you about 30 seconds on the number 4. 30 seconds.
It would be 3 to the 5th. So it would be log 3 to 5 equals 5.
That's 3 to the
Okay, what's my answer? What's log base 3 of 243, everyone?
5.
Good, 5 is the correct answer, right? All right, I don't need to work it out, but you should know the procedure. Next one, number 5. Log base 5 of 125th. This one's like number 2. Yep, x is equal to negative 2, that's right. Next one, number 6. That's right. Next one. Number 7. Number 7. 20 seconds. So 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. 2 to the fourth is 16. 2 to the fifth is... Okay, let's keep going. 2 to the fifth is 32. 2 to the sixth is positive 64. Okay, good. So 2 to the negative... Listen. 2 to the negative 6 is positive 1/64.
So it would be negative 2.
Positive 5, it's going to be 32. That's incorrect. So I got a question for you. We're all confused right now because think about it. Is there any number you can or what power can you raise 2 to? Eyes up here. What power can you raise 2 to that'll be a negative answer? Is there anything you can raise 2 to so that the answer is negative?
No solution.
No solution. That's correct. Right? Raise your hand if you were confused on that one. Okay, good. I want you to be confused sometimes because I want you to think about it, right? So, you have to be careful. You have to be logical. 2 to what power is equal to a negative answer? Nothing. There's nothing that's going to work. So this is no solution, okay? Same thing on number 8, okay? Someone said in the morning 5 to the 1/3. Does 5 to the 1/3 work?
Not physically possible, no.
Or, yeah. So no solution, okay? Okay, that's it. So that concludes the lesson. I'd like you to do a little practice here. So what I'd like you to do, I got 8 problems. 8 problems. I'll give you 3 minutes because I think you can do them in 3 minutes. Okay? Pause the video here and practice these. for a few minutes, and then I'll show you the answer. Check your work here, okay?
Oh my gosh.
Okay, number 5 is good. What do you know? What do you know about 5? What's anything to or what would you make anything a power of to make it an answer of 1? 0. Okay, good. Number 6. Raise your hand if you're confused about number 6. Okay, cool. So number 6, there's 2 ways you could do it. Okay, so number 6, you can rewrite this equals to x, right? Just like I taught you, and then you would rewrite this as 16 to the x power is equal to 4, right? What's a common base you could use for any of these? 4, right? So, let's do 4, okay? So I'm going to rewrite this as 4 squared, right? Isn't 16 just like saying 4 squared? Would you agree with that?
That is just like that.
Okay, and then you bring down the x is equal to 4 to the first power. And then we have to raise the power by a power, so we're going to multiply 2 times x is 2x. So it'll be 4 to the 2x is equal to 4 to the first. And then you get 2x is equal to 1. You solve, you get x is equal to 1/2. Okay? That's one way to do it. You want to see a different way to do it?
Yeah.
This is a way a student in first period figured out on his own. He took this original equation and he rewrote it as this, right? Isn't 4 the same thing as the square root of 16? Would you agree with that? And isn't square root of 16 just like saying 16 to the 1/2 power? Would you agree with that?
Yeah.
Therefore, x is equal to 1/2. Okay? Does it matter which way you do it? No, you got the same answer. Okay? That's it. All right, that concludes the lesson.